Food? Yeah. So ask her for next time, or something different. Oh. No? Yeah. Please vote. Press your red button and vote for the food for next time. So for our next speaker from the University of Delft, already delivered one student who's now employed. Is he still? Well, Dirk already left. But Dirk comes from her group, and you also helped him during his final internship. Now we're also getting a new intern. Jelmer is really happy with his intern. Still looking for a marketing intern to organize SaKE. We're quite happy with how he's doing. Really interesting title. So we're looking forward to your talk. Assistant professor at the TU Delft, Claudia. Do you have the mic, by the way? Oh, sorry, you forgot to mic you. Yeah, but there's people in Finland, and you can't shout that far.
That is a very good comeback. Okay.
Or in Hungary, or in, I don't know where everyone's from. Russia? Did you forward the link to people in Russia?
My parents.
Ah! I didn't see them in the show notes, but I'll ask them to comment. Okay, audio, Jelmer?
Does it work?
Yep.
Okay,
Great. Take it away.
Well, thank you for the introduction. So, well, as you already just heard, so I'm assistant professor in the Web Information Systems group, and when Jelmer asked me to give a presentation, I really jumped at it because we do a lot of research in our little corner of the university, but actually rarely ever do we get the chance to tell it to industry and then get some feedback whether this is actually useful to you as well. Just a bit to my background, so I'm really a core information retrieval researcher. I did my PhD in that area. So to me, search engines and everything that has to do with search is really very, very close to my heart. And this one here is a very recent work we did a couple of months ago together with Morgan Harvey and David Elsweller, who are also researchers in IR. Morgan is in Northumbria and David is actually in Regensburg in Germany. So what does this long title mean? Well, this is DuckDuckGo. Who does know what this is? Who uses this search engine? Okay. It's a very cool search engine that everybody should use. And these are the statistics of how DuckDuckGo developed over time. And as you can see, initially there's not much going on. People use it, but oh, it's so la la. And then something happened, and well, all of you know that this is the NSA scandal, where suddenly people realized what is happening in the world, and people went and used DuckDuckGo, at least for a while. And we were really curious about these little bumps. So this is a public DuckDuckGo data that you can just play with yourself. And as you see in these little bumps, that people tried it, but they were a bit, well, not too happy with it. So they went there, and then they said, well, maybe not. And we were really curious, why is this happening? What's wrong with DuckDuckGo? Because it uses Bing, and Bing is objectively not much worse than Google. So in theory, there should not be a big difference, and people should actually be happy with it. But people were not. And we wanted to know why. And this is how all of this came to play. And then we looked, well, this is only anecdotal evidence. So we looked at Twitter where people say, wow, this is great, I'm going to try it. And then they started complaining en masse. And you find a lot of tweets where people say, well, I can't find anything. I have to switch back to Google. It's Bing. Bing is not good. And people were genuinely very unhappy. And so they did care about privacy, but as soon as they saw searches work, they said, well, screw it. I go back to Google, even though there's zero privacy. And the question we ask ourselves is, what can we do to actually change that situation? So how can we teach searchers to become better at a particular search engine? So we assume that DuckDuckGo is actually not worse than Google. It's just different, right? And people are so used to Google in this case that they have a very hard time adapting search strategies, adapting the manner of searching to a new engine. And we really wanted to know, well, is this something that we cannot fix? Or is there a way that we can teach people to really become good searchers at a specific search engine, which is not their main one? And if you look at the search literature, there are many approaches to improve search, right? And you probably know all of them already. So one of the mainstream technologies that we use as information retrieval researchers is really we try to make our machine learning approaches better. We have learning to rank, and we really, really optimize it. But in all of these cases, we assume you as a user, you put in a single query, and we cannot fix you. We just assume this is the query, and now we try to build the best algorithm that infers as much as possible about the query. Now, we can also assist the user in creating better queries. And again, this is something you're all familiar with. So we have these query suggestions. We can offer related searches, what Google and Bing are doing. Or we can do auto-completion, which is the standard today. Now, an alternative is to also be personalized, right? I look at your search history. I know what kind of sites you tend to like. So I try to adapt my search ranking to your liking. Now, the last alternative, and that's the one we focus on in this work, is really we want to educate users. So I don't want to just give them something and say, well, this is what you should use. I really want them to educate and learn how to make good queries themselves. Right? This is the main goal. And the cool thing about this approach is that it's really complementary to all the technological approaches you see above. So if we can educate the searcher to become a better searcher, we also improve when we add machine learning, when we add personalization and so on. And this is really a system-specific thing. So if you have searchers, for instance, that are really bad at startpagina, this is an approach you could try to actually make them good searchers in startpagina, which is one specific engine. So, and this is what I will focus the rest of the talk. And as you will see, we don't have tens of thousands of users. We really do small-scale experiments, but we do them very thoroughly to actually see whether or not there are effects on what we are trying to do. We're actually trying to build here is what's called behavior change support systems. I just realized I see my slide there too, so I don't have to look here. Excellent. So what is a behavior change support system? Well, it's an information system designed to form, alter, or reinforce attitudes or behaviors without using coercion or deception. So without being bad, you build machines, algorithms, methods that try to push the user in the right direction. And this has been done actually quite a lot. And if you have a quick look what I mentioned here, all these approaches that try to nudge the user in the right direction are really simple. So even altering the search box has actually a big effect, right? If I make the search box longer, people tend to write longer queries. If I color the search box and give like good and bad colors, and depending on the length, again, this changes how people feel and how they input queries. We also know that people can be trained to use Boolean queries, although nowadays that's less of a method. And we also know that if we go all the way and we build a dashboard that shows people how bad they are in comparison to expert users, they actually can use this kind of knowledge to get better, right? But this is actually hard to do, and might also make the people not feel good about themselves. So we want to avoid the, telling them, okay, this is the expert and this is you, so there's a big gap, so try to go there, right? So we try a different approach that, just helps the user along. So what are we actually trying to do? So, so this is academia, so we had to build a search engine, and we just use Lucene as the underlying search system, and we use one of the academic corpora. Now, it looks very standard. The main thing is up there, and this is how we try to educate searchers. So we give them a topic. This is what you have to search documents for. And then we tell them, well, based on your query that you put in, we know there are better ones. And those are the better ones. So we know this in advance because we've given them these topics. So this is a training topic. We've given them the topic, and they put in a query, and we know there are many better queries, and we show them to the user. And then we hypothesize that even just showing these better queries enables the users to actually learn from them, right? So, and the specific questions we had were these two. So, if we tell users they are better queries, not just different ones, they're better ones. If you tell them these are better, are people able to actually abstract from these better queries and kind of find general notions of better strategies? So, for instance, if I show them lots of these query suggestions that are longer than their own query. Do they realize, oh, I should put in a longer query? If I show them suggestions that have very specific terms and their own query is very general, do they realize I have to become more specific in my terminology? And the second question we had is then, well, assuming they can learn, do they actually learn differently if they get queries that they can relate to, or if they get queries they cannot really relate to? So does it actually make a difference whether or not these are familiar query suggestions? Now, while at Sanoma you could do a lot of A/B testing, in my setting, academia, this is not possible. So we actually had to run a bunch of user studies. And well, we run a bit more, but I show you here 3 user studies. And before I can show you what these studies all did, I just have to go a bit about how did we generate these query suggestions where we know they're really good, right? And well, we had a few requirements for this. So we wanted suggestions that are at least intuitive and that are also too different from web queries. So if you whole sentences, oh, this is a really good query suggestion, well, people will not like this, right? So they should not be overly long. They should not be overly weird. And in academia, we use a lot of track corpora. So these are document collections where we have topics and we know what are the relevant documents. So we can very easily build query suggestions that we know these are really good for this particular topic. And this is what we did. And actually, well, the main point is down here. So we generated for each topic, I'll show you in a second what I mean, we have query suggestions that we know are good. So here are 2 examples. So on the left-hand side, you see the topics. So this is what comes from our test collection. In your case, you would probably pick queries that a lot of people put in at Sanoma, right? Or Sanoma at Startpagina, for instance. So if you know that buying a car is very popular at Startpagina, then this might be one query that you put in as a topic, or you develop a topic around this, and then you come up with a few queries. And these are the suggestions we automatically generated by our approach, by just looking, okay, what are actually the good documents and how can I retrieve them to the top of the ranking? Well, if I create these queries, then I get the right documents at the top of my ranking. So these are the suggestions I should actually give to the user. And then I should see whether or not the user can actually work with these suggestions. And as you can see, I mean, they kind of make sense. Although in the second case, so if the topic is identify drugs used in the treatment of mental illness, you have to already know what those drugs are. So the best suggestions are those where you can actually name the drugs. So what we did here is we then had these good query suggestions, and we wanted to know what people believe of them. So do people actually think these are good or not? And this was the first user. So we wanted to see what is the perception of users. Do they actually believe these are good suggestions? Now, if we're doing really well and we create suggestions that are very Google-like or Bing-like, then people would say, great, yeah, I totally believe in this suggestion. So we ran a crowdsourcing study where we gave people the topic that we had, so identify positive accomplishments of the Hubble telescope, and then said, well, this is our suggestion. What do you think? Do you think this will give you good search results? Is it surprising? And so on. So you see the 4 dimensions there. And we used Crowdflower. We paid very little money, but surprisingly, it still worked. And here's the result. So how surprised were the people by our suggestions? So, well, as you can see, most of them were not really surprised, which is good, because it means that our approach to generate these good suggestions is actually valid. And this is actually very important because we want to train people on a set of topics we know about, and then we let them go off into the wild once they're trained. So it was very important that we have an approach that generates valid query suggestions. Now, this was a bit negative. So would you actually use this suggestion? No. Well, most people said no. They made sense to them, but they still were not really convinced that these would be good. Many of our suggestions are not convincing, which actually suggests that the system we have is quite different from Google, right? Which is good in a way, because if we still get improvements later on, it means we can actually educate people to use systems which are very different from Google. So they didn't believe us that these would be good. But for our system that we have, These were actually the best possible suggestions we could give. Now, and then we also asked them just as a confirmation, so what do you think the quality of the ranking will be? And as you see, very few people believe this would be high quality ranking. So most said, well, it's probably average, but definitely not good. Again, suggesting that the search system we built is quite different from Google or Bing or your favorite search engine. Okay. So the last point I want to make is that, well, as I think you can expect, that when it comes to the interestingness, so which kind of topics would you actually use? If I give you a couple, most people felt most comfortable with like general topics, so like shopping or, well, drugs. And they did not like topics that were very specific. In this case, a particular building project in the US. Which, yeah, it's not surprising, but it's good to know if you try to build your own kind of tutorials. Okay, so having created and shown that these suggestions are surprising to users and are not your standard suggestions, but still the best for our system, we then went and we wanted to see, well, can people abstract from them, right? If I give you a suggestion, can you tell me why this is better? And this is how we did what we did. So here's Zing again, and now I explain a little bit more in detail. So what we did is that when you put in a query, the first time we don't give you any suggestion. The second time we give you suggestions, but we only give you those where we know they will get better results than what you put in, right? If you already wrote the query that gives the perfect ranking, we actually don't suggest anything. So unlike Google, for instance, which gives you related searches, we only give you those where we know they're better. And then to keep people engaged, we actually also showed them, well, how well you're doing, because this is for training purposes, right? So we want to train them, so we want to give them an idea, how well are you here? Right? So we show them how many relevant documents are in the top 20 and what kind of score they have. And we also, well, this is hard to see here, but we also mark the relevant documents, again, to enable people to actually look at the snippet and think about why is this now relevant to this topic. Okay, and then we ran a pilot. And for that, actually, David used one of his classes, surprisingly, and all his students had to run, which was very cool, but, well, hard work for them, because they had to actually run through 10 topics and search for like 5 minutes per topic, which is a long time. So the first question we actually had is, well, can we do this? How long can we actually do this? When do people completely give up? And as you see here in this example, in this graph, by the time the students had done 7 topics, they were completely tired. So they were not able to get good results anymore. So we should definitely not have more than 7 topics for training. Ideally, we actually only have 1 or 2. But the more interesting one was, can you actually tell me, so we also asked them, when you use a query suggestion that we give you and say this is better than yours, can you tell me why this is better? And surprisingly, the students were actually able to really tell what was going on. So they could say, well, for instance, they use more specific query terms, or the more general query terms. They also commented when something was unexpected or surprising. So we hand-coded this ourselves, and the main outcome was here really is that users are able to identify these characteristics of these better suggestions. Even though they might not believe in them, they're able to tell you why are these better. And that's very important for us. Now comes the study, because that's the one where we actually wanted to see whether people learn. So do they actually learn from this training we can give them? Now what we did here is the following. We had 2 experimental groups, and we trained both of them with these high quality suggestions, but one of the groups got those suggestions that in our perception study people said, well, these must be really bad queries. And the other group got those suggestions where in the perception study people said, oh, these must be really good suggestions. And then we did the following. We let them do 6 topics, because by 7 they break down, so we let do 6 only. And the first 4 topics, we gave them the query suggestions as well. So they could search, And we said, well, these are better queries for you. Try to use those. We didn't force them, but they could do this. And they did this for 4 topics. And then for the final 2 topics, this is the test phase. We said, well, now you can't get any suggestions. Just search and see what happens. And then, of course, we also need a control group. And these are the ones that don't receive any training. So these poor people actually had to do 6 topics without any suggestions, right? And the hypothesis that we have is that people here, they should have learned how to search on our search system, which has been shown to be very different from Google. And if indeed they have learned it based on our suggestions, then they should do much better on these topics here, on the test topics, where none of the people received any suggestions. And so, again, we used Crowdflower, which served our purpose very well. We had about 91 people. And the outcome. So the important graph is this one, which shows very nicely what we want. So on the left-hand side for you, we have these training topics where here you see the 3 experimental groups, experimental high, experimental low, and control. And the height of the bar shows you how well the queries, how effective the queries were the people put in. So this is average precision, right? And you can see that for training overall, the groups are fairly the same. You don't find much of a difference. In the test phase, however, you see a clear distinction. So the both experimental groups do much better than the control group. The people here have learned how to put good queries into our system, right? We gave them, in this case, 4 topics they could train on, and we later did a study with 2 topics, and it still had the same effect. And you can see when we take the suggestions away, they are still continuing the same behavior that we showed them to be good. So we were actually able to train our users to our system just by showing them the right suggestions, instead of just showing them suggestions that you generate from a query flow graph where you say, well, lots of people put in this query, that should work, right? We said, well, we really train you on what we know is good for our system. Does this work? And yes, it does work, and all these differences are actually significant. So users who receive these high-quality training suggestions perform much better than users who do not receive the training, indicating that learning actually takes place. Now, the last graph I want to show is just a different representation of the same result. So again, we have the 2 experimental groups, green and blue, and the control group here at the bottom. And what you see here is the query sequence. So we looked at, OK, now you've put in 6 queries, 7 queries, 8 queries. What is your average precision at that point? And then again, we just average it across the groups. Now, as you can see in the beginning, there's not much difference, because at the first time people start searching, even with our training setup, they don't have a clue. So there's not much of a difference between the control group and the experimental groups, because they have not learned yet. However, by the end, you can see that there's a big gap. So the control group hasn't learned anything. They're still having the same behavior as at query 1, 2, 3. But you can see that both experimental groups, by query 10, they have learned. So just within a few queries, they have learned how to use our system much, much better. Now, the one surprising, so it's not surprising that there is this difference, but the one surprising fact for us was that actually it doesn't matter how weird the suggestions are we give them, because we didn't find a big difference between both experimental groups, the one that got these relatable query suggestions and those that did not get them. So even if the suggestions are a bit weird, people adapt. They're happy to learn, OK, this is the way the system works, right? As long as the results in the end are actually good. So to wrap it all up, what did we learn from this study? What did we try to do? So we learned that, yes, users can adapt their querying behavior very quickly. They're able to abstract away these unique characteristics of good queries for a particular system, even if that system is quite different from what they're used to. And, well, I didn't show it here, but we also did a study on how many training topics do they need. And even at 2 topics, which is very little work for the users, we get significant differences. Now, negative result was, or actually it's good for practical purposes, that it really doesn't matter how weird these suggestions are as long as they're better. People accept them if they really give you a better result. Okay, so that was what we did, and now it's just the looking ahead left. So we ran the study on a single session, and of course in a lab setup this is okay, right? But if you say you want to train startpagina users, of course this would not work. You cannot force them for 10 minutes to search on one topic that you give them. You have to build a better setup that maybe crosses different sessions. So the next step we have is, instead of doing one session, we force people to attend more or less. What happens if I try to learn them across sessions? How small can I make these learning nuggets so that people actually really do learn and move into the direction that I want as a search system? Now, the second point is then, how do I translate this approach into, well, again, your setup, for instance. So we had this training corpus where we knew these are the relevant documents, which in a way you don't have if you look at startpagina. You might have lots of clicks on certain documents, so you can infer these are probably relevant to your use case, but it's not as clear. So then the question really becomes, okay, how can I adapt this lab setting, which has shown to work very well, to the real world, right, to your application. And then, of course, the last question, which we actually did not touch upon at all so far, is how should you actually present these suggestions? Now, we have been very direct. We just said, these are better. Try them. This might not be the best way to present these suggestions to the users and to make them use. So in practice, as you all know, probably, very little differences in the UI can have a big impact on users. So how should you do this? How do you go about training them without being too obvious about it? So these are the three directions we're trying to work on right now. And this is it. Thank you very much.
Hi. Thank you for your presentation. I was wondering, why should we educate users on talking computer instead of teaching computers to talk human? Because what you're doing with the suggestions, you can do it in the background and maybe understand better what people want to search for, and don't present the translation of that to the user, but just leave it in your own system.
Well, actually, what you say works for obvious, let's say for easy queries, right, where we know the intent of the user. But often we actually don't know the intent, right? So in this setup, you choose training queries where you know exactly what the intent is. And then you hope that the user learns. But when the user has learned it, then he can use these newly learned skills to actually better represent his intent for harder queries. So I think as long as we are on very simple queries, this works. But in research, the one big question we have is really, how do I infer intent? If you give me gibberish, how can I know what your intent is, right? You know, yeah, but the search system usually does not.
Yeah, I thought it was very interesting to try to do it in a different way. I had two questions. So the first question was, it wasn't really clear to me how many tries did each person get. Like, do they just put in one query and then the score is calculated? Or do they get multiple tries and they can also try out the suggested query, for example?
Yes, so because we use Crowdflower, we had this little gamified element where we really said, you see your score, and then people actually tried to improve the score. And they could, it was open-ended. So we said, try to get as many relevant documents to the top as you can. And because they saw the score, they kind of felt, okay, the score is still 0. I should probably try more. What we did, though, was that if you get the topic, for instance, you have to search for Hubble telescope achievements, then the first 2 queries you have to put in yourself, and then we give you suggestions. So we did not start from the beginning with suggestions. We let people start themselves. But at some point, we intervened and said, we know there are better queries. Please use them.
But when do you measure their performance? Is it at the last query they put in for,
No,
for
we
that
measured
specific question, or?
So we only measured the performance for the test queries where they get 0 suggestions. Because by that time they have learned.
Well, yeah,
to
but
use
you
the
also
system.
showed, you know, the performance overall.
Yeah, that was for the first 2 queries where they did not receive suggestions either. Yeah, because if they receive a suggestion, then of course.
Yeah, no,
they're better.
that was what I was getting to. That when they, you know, use a suggestion and they see that it works, that can amplify sort of the result.
Yeah,
and
so
that
what
also leads to my second question.
Yeah.
Did the control group see their performance, or?
Yes, they saw. They had exactly the same interface without the
Without the-
suggestions.
Okay, because it would be interesting to see whether just showing how well they're doing already influences their search results, their search queries, right?
It definitely, well, at least on Crowdflower, it definitely makes them search longer. So we had one experiment where we did not add any gamified interface, and they did one query. Okay, thank you. Next. But as soon as we added this little game element, and we said, okay, one is what you should aim for, people really tried because they had a focus. They knew what the end goal was. Whereas if we just say, please search, they don't really have any idea of what they actually have to do. So initially we didn't have that, and then we added it because it really made a difference to how much people actually search and use the system. Yeah, but this is very specific, I think, to the crowdsourcing setup we used.
Final question.
Hi, this is kind of related to the question he was asking. Do you account at all for bias in your current model? So in a way you gamify the experience, but are the user actually trying to achieve the better results they perceive as the best, or the best result they perceive for improving a score? And also somewhat related, how transferable are these skills? So I train my users to do better searches, but how much of this training is actually biased in learning how to play a system very well? And then if I move to another system, say from StartPagina to something else, maybe I have to relearn from scratch.
Yes, so I mean, that is the whole point, right? We want to train people to be good at one specific system. We know that people are good at general web search, which, Google Bing, there's not much of a difference. And we wanted to test whether they're quickly able to learn a new system. So what they just learned is only specific to that one system, right? When they move to StartPagina, they might even actually do worse than initially. But then they get 1 or 2 training queries, or topics, sorry, and then they're up to standard again. So what we're also right now working on is what happens if I have 3 different systems in a row, right? Does it interfere? Do people get completely confused, and by the end they actually don't know at all how to search?
Especially if you interleave systems. So if I switch from one system to another, how do I cognitively?
Yeah.
How am I able to?
Yeah. So actually, one of the practical settings for us is that as researchers, we often build systems, and we actually want our users not to be biased by how they search on Google, right? So this initial training phase that we tested is very good to give them like common playing field, and then once they have been trained on our system, then we actually run our experiments on that.
Okay, thanks.
Cool, thank you.
Thank you.
So another round of applause for Claudia.